Well, thank you everyone for being here, for being at Spectra, and for showing your interest in Particle Workbench. Before I get started, just maybe a round of applause. Who applauds in the keynote and was excited by Visual Studio Code, just so we get a sense of... Okay, cool. Yeah, so we're super excited about it. Again, my name is Jonathan Beri. I'm a product manager here at Particle. And actually in this workshop, we have a bunch of friends here. I'm joined by the tech lead, Matt, who's in the back, Matt Morand, who worked on Particle Workbench. And we have our friends from Microsoft as well. Just a wave here? Yeah, cool. Who work on Visual Studio Code and Azure. And what I want to use this time is to walk through in a little bit more detail, a little bit more code, showing a little bit behind the curtains of Particle Workbench. Before we get to there, I want to talk about the history of tools at Particle. When we launched Particle back in 2013, we wanted to solve a problem of building embedded systems. And we noticed that a lot of platforms out there required you to download a tool chain, configure it to work with your system. Maybe it worked on Mac, maybe it didn't. You had compiler issues. And we wanted to remove all of that by introducing a web IDE. And if you've used Particle in the past, you know we have this really easy-to-use web interface that you type in your code, you push a button, and then the code gets on the device. Actually, behind the scenes, we have a very complex and now mature cloud compiling infrastructure that was born, pre-Docker, and now is all Dockerized and does all the things that you would do if you were to configure a Linux machine to be very performant and running in the cloud. And that's been great, and that's the thing that the developers cite, the number one or number two feature that they love most about Particle. It's cloud compilation, it's OTA. And even professional developers say that's one of the reasons they've picked up Particle as their IoT platform, and it's been treating us well for a bunch of years. But hey, come on in. As Particle grew, and we went from really catering to the makers of the world to introducing more makers and even more professional engineers, we started to hear some feedback about having a web-based code editor. You could say that the experienced developers strongly requested a desktop experience to match our web IDE. And we listened, and in 2014, we built what was then called Particle Dev, which is our previous generation desktop IDE. And it was built around a platform, a code editing platform called Atom, which was really popular at the time. It was really easy for us to integrate our different tools to hook into that cloud compiler and have a local experience. And so that's been running for a couple years, and those same developers who strongly requested a desktop experience gave us even more feedback about Dev. Well, it didn't quite meet their needs. One, it had some performance bottlenecks. You can point to Atom, you can point to Dev itself, but as you start to build more advanced applications with larger code bases, multiple files, the tool was slow. It's great for doing quick edits, but it really didn't scale. Also, it used that same cloud compiler backend to do all the compilation, which was convenient and easy, but it meant it didn't work offline. So if you didn't have a good cloud connection, or if you're on the road, it basically was this equivalent to a web IDE in some respects. And truthfully, it's a simplistic editor. I use a screwdriver reference because sometimes you really need a drill, not a screwdriver, and that's kind of the features it delivered. It wasn't really optimized for building embedded C++ code. It didn't have any debugging, and so we took that to heart. And we decided we're going to go build a whole new desktop experience. And you guys all saw a sneak preview of that this morning. And we set on solving some more problems, not just those three of performance, local compilation, and power tools. One, we wanted to make sure that it worked everywhere. So that means the major operating systems that developers use. So that's Mac OS, Windows, and Linux. We wanted to be really optimized for C++ and writing in the language that you program these devices in. And that also means that the compilers have to work on Windows, Mac, and Linux very well and very reliably. We wanted to be both local and offline, so it didn't rely on the cloud compiler to do all of the compilation. And you can program the devices over the wire, which is also a nice convenience. And as you build those more sophisticated applications, wanted to introduce debugging and eventually diagnostics. After we were looking around and trying to decide what do we build Workbench on, We've been keeping an eye on this little thing that some of you may have heard of this morning called Visual Studio Code. Launched in 2015. It kind of came out of nowhere. Caught us by surprise. It just launched a year after Atom, actually. And as Amanda was talking about this morning, the most loved code editor basically on the planet, supported by a major company like Microsoft. And we started talking with the Microsoft team, and they said, "Hey, we can help you get this to market." So the history lesson's over. Let's start looking back at Workbench like we saw this morning and start writing some code. I have a bunch of things I want to walk through. I'm going to keep this a little bit casual, especially if things go wrong. And if things go wrong, I'm going to look at Matt to tell me what I did wrong. But feel free to also ask questions as I go through. Sound good? Cool. All right, let's break out of Slyland and get back to Workbench. Well, that's going to be too tiny for everyone. Let me bump up the resolution. So the first thing you might be thinking, if you missed the keynote or you're snoozing through it, is where's Particle, right? This looks like Visual Studio Code, and that's the point. Because Particle Workbench is built on Visual Studio Code, it is the entire Visual Studio Code experience that we get to build upon and add Particle to it. So Particle is really in the background, and I'll show where that comes through. But also know that if you're used to Visual Studio Code and you love using it, you can use all the same configurations and extensions. And as Visual Studio Code gets better, Particle Workbench does too. All right, so we got a lot of applause. I'm not going to explain every part in detail, but if you're new to Visual Studio Code, the interface you're going to learn to love really quickly is the command palette. And the command palette is a text-based interface that you drive a whole bunch of things you want to do through Visual Studio Code. And we've added a whole bunch of commands to the command palette such that you can do the local compilation, etc. And the way to discover those is just starting to type Particle, and you'll see a list of all the commands that are in the initial release. And we'll add more commands over time, improve the commands based off feedback. But this is kind of like your home base for working with Workbench. And to just show you, it has a nice fuzzy search. I can start typing "who am I?" and it's going to see that I'm logged in, hopefully, with a little toast in the right. Yeah, there we go. I'm logged into my work account. Yeah, feel free to email me with feedback. And we'll be using that for the rest of the workshop, and you'll be using that as the primary way to sort of drive Workbench. In the keynote, I had a pre-built project. We're going to go from start to finish, hoping for all the demo gods and hardware and all the internet fairies to bless us today. So forgive me if things don't work, but we're gonna try it, okay? And I'll start by firing up the palette and creating a new Particle project. I don't have to type out the whole thing, and I'll hit enter. Okay, I'm in the wrong directory. 1 second. And try that one more time. Create a new project. Okay. They warned me against live demos, but I had nothing else to talk about. Let's get back into the right starting place. All right, this is where I want to start in the beginning and create that project one more time. I'm going to call it Leaky Lenny. It's an internal joke. And I've created a new Particle project. Behind the scenes, Workbench is scaffolding out all the folders and the files that both Particle needs as well as Visual Studio Code needs to set up the environment in the correct way. As you saw, it was just a simple command to create that project, and there's a whole lot of stuff behind the scenes that we're gonna dive into. But if you used Particle before, if you use the web ID, you'll see this familiar .ino file. We also support C++, and we'll show that in a little bit. But I can start typing like I did in the keynote. So if I start picking up Particle, particle.publish, and this is what you saw. It's auto-completing based off of the IntelliSense in Visual Studio Code and the C++ extension from Microsoft, as well as the behind-the-scenes wiring up of the device OS. It wouldn't be easy to do this on your own because we use all the APIs provided by the Visual Studio Code's extension framework. But I just do, again, 10 degrees Celsius and save it. So while in the bottom right corner, you might have seen, too quick. The little red flame or the little database, that's the IntelliSense in Visual Studio Code, parsing device OS, building out the references to the actual source code, both our source code and the device OS, and creating a way to do that, the referencing. So I'll hover over the publish once again and peek to definition. And so what this is doing is now referencing where that function is defined in the device OS for this particular configuration, and allowing me to go and scroll through those function definitions. And it'll work with any API that's available in the device OS. And as I was closing out that the keynote demo, I mentioned we have a dependency manager, and it was a lot of work, and I'm going to tell you a little bit about that now. The cloud compiler we built, and that's used by the Web ID, is this Docker-based thing that automatically pulls in all the right source codes and compiles libraries all behind the scenes. But now we're trying to run all that on a local machine, on your local machine, which we don't know much about the environment, and across different operating systems. So the dependency manager is, as the name implies, pulls on all the dependencies you need to start using Particle Workbench. That includes different versions of the device OS. That includes our compiler and build system. That includes tools for things like debugging, and et cetera. And it's dynamic, so as we release new versions of the device OS and support for new platforms, they'll be added to Particle Workbench through the dependency manager. And we try to do our best job at isolating that from your environment, such that if you have a custom configuration, we make sure that's in the user space and doesn't collide with your existing files, because we're adding a bunch of stuff that could wreak havoc, especially if you're an embedded engineer with existing tool chains. But that's nice because we can guarantee if you set up a new machine, it'll just work right out of the box. So the dependency manager also includes different versions of device OS. So how do I switch to a different version of the device OS? On this machine, what did I prepare? We'll see. Let's say I want to uninstall or install a new version of the device OS. I already have 0.7.0, which is the latest default version, as well as 0.5.5. Let's see what happens if I try to install 0.6.3. It may work, and it may not. Install, but it's as simple as set firmware. Particle commands to the rescue. That's why he's here. So just setting the different firmware version. Right now we have a couple deployed in our dependency manager infrastructure, but if I just type in 0.6.3, you can see we have notifications to tell you that it's downloading. If I did 0.5.5, it'd see that's already in the machine and not worry about it. But in the bottom, we're notifying you of that, the insider baseball of how this is working. I have all the right build tools, I have all the right build scripts, and the device OS version, quick and easy. I need to get a new compiler. And so it's downloading GCC ARM, which is known to work and designed to work with device OS version 0.6.3. It's going to take a while. Now it's validating to make sure we didn't get the wrong version and that we didn't get spoofed. And as I do that, I'll show you another feature. This is a nice light theme. We've designed 2 new themes for Particle Workbench. I'm personally a dark theme person, but it doesn't show up that well on the screen. So we'll try out dark matter. This is I've been coding for the last few weeks. Looks nice. And if you don't like these themes, there's a bunch of themes that are built into Visual Studio Code. There are more themes on the Visual Studio Code marketplace, and you can even customize our theme through the settings configuration if it doesn't meet your needs. So I'll go back to the light theme as it continues to download some more. The other thing that's built into the Workbench is we're taking advantage of Visual Studio Code's snippet system. So snippets, little snippets of code. It saves you typing a lot of the repetitive things that you might do all the time. For example, if I do digital write and tab, it's going to autocomplete the digital write function and have this nice way of inputting data. I can just start typing D7, if I do it correctly, tab to the next field, select the high value, and now we're good to go. And it's for all the major wiring compatible APIs as well as the particle primitives. And that GCC ARM is a big beast. We'll let it keep on going. In the meantime, I'm going to keep on going. I didn't really tell the Workbench which device I'm working with or even which platform. So you can set the target platform. And behind the scenes, Particle Workbench will make sure that the right device OS and the right functions for that platform is wired up, so things like IntelliSense just work and compilation just work. So I'm going to do that again with the command palette and particle set target platform. Pick from the ones that I have an electron on my desk or on this podium, and it will continue to go. I will set this back to using 0.7, set firmware version, just because it's going to be angry with me, and it's probably going to blow up in my face, but we'll do a quick reload while that's happening. We have to rewrite all the paths to point to 0.7 and now to electron, and let the IntelliSense catch up as we keep on hammering on it. But if all is going smoothly, I can start calling one of the modules that are specific to the electron, and there you go. The cellular module now shows up in the IntelliSense because it's now set as an electron. Cool. Now that we have that there, I quickly glossed over compilation and flashing, but we have obviously built-in support for local compilation, as well as over-the-wire programming. That's using DFU and our build system in the same way you would if you were to set up this environment yourself. So I'm going to try my best and hope for the best and put this device into DFU mode so it can be ready to be programmed. And it's actually really convenient if you're doing cellular-based projects, because if you're just relying on OTA, then that uses data and that costs you money. So if you're rapidly iterating on a cellular-based product, you're wasting money during that R&D phase. Using over-the-wire programming and local compilation, you can just do that same rapid development without paying extra for it. So like the command palette, Visual Studio Code has tasks. And there are default tasks like build and test, as well as custom tasks. And we're just using build tasks. So we can take advantage of the keyboard shortcut for that, which is Command-Shift-B. Very similar to the command palette, but for the task. And we're behind the scenes dynamically generating those, because depending on how you configured your project, we might have to have different values we pass through to the build system. But I'm just going to go ahead and flash and compile and flash this device. So it does 2 in 1, and we'll let it go. All right, great. So the user application was tiny. It got flashed real quick. If you're building this for the first time, you might want to build the application and the OS and the app. In subsequent builds, you can just do the user application, so it's way quicker. Great, so file downloaded successfully, and if you can see all the way in the back, it's now blinking cyan because it's programmed in trying to get back on that 3G network, and it's breathing cyan. Cool. So that's a real device, local compilation, and local programming. And you'll also notice this is a .ino file. For those familiar with the Arduino world, we support wiring-based programming model, and which is really just C++ in green skin. But we also support C++. And if you look actually at the output directory, you can see we have a built-in preprocessor. That's how we convert the INO files to C++ files behind the scenes. And I could have written this application in just pure C++, have all the same IntelliSense, have all the same compilation and programming. It's just a convenience depending on what you're comfortable with. Now, you saw the commands I have. We have a bunch of built-in commands in the command palette. And for everything else, we leverage our Particle CLI. And so with Particle Workbench, we're actually installing a local copy, a private copy of the CLI with the Workbench, so you don't have to do that yourself. That also means we can keep it up to date and put that in the user path for Workbench purposes, as well as your own, as calling it directly. So if I were to go ahead and fire up the Particle CLI, this is just going to open up an instance of the integrated terminal with the local copy of the CLI already wired up, and I can start doing particle commands, and this should be familiar if you've used the Particle CLI. But now it's just one-click install with the rest of Workbench. That also means if there are features not quite implemented yet in Particle Workbench, but they are in the CLI, you can use them, and you can use them in conjunction. So, oh, cool. I got plenty of time. For example, if I wanted to program over the air, let's say I didn't want to use over the wire for some reason, maybe the device is not nearby. I can still use the over-the-air programming features of the Particle Cloud, but build my application locally. So what I'm going to do is first tell Workbench which device I want to program over the wire, over the air, and then go ahead and fire it up. So I can go ahead and say, using the CLI, just do a particle list and see all my devices. These are all the devices connected to my account. And so this device right here is my Office Electron. I could set the target device using its device name, or I can use the device ID, depending on how you manage your devices. So for demonstration purposes, I'm going to grab the Particle Electron device ID, and then set the target device. So I'm going to go ahead and set the target device. All right, set the target device. So now when I do a cloud compile, Workbench knows which device to find and reprogram. So fingers crossed, everyone. Keyboards crossed, whatever. Let's do Flash, and we're going to do a Cloud Flash. And if you are in the front row, I don't know, let's see what happens. It's saying preparing to program, and now it's going to magenta, and rebooted, and connecting back online. So it's actually using the local application that I built, so I can do my own custom functionality, whatever I need, and then still program over the air. And that's with the convenience of the CLI built into Workbench. I also showed libraries and library support. Real quick, we have over 3,000 libraries that are built for the device OS. Those are things for like sensors and motors and protocols, and you have access to all of those libraries that are available in the web ID right on the desktop ID, or in the Particle Workbench. We can go ahead and just sort of install library. I used the Asset Tracker demo, Asset Tracker library this morning. Let's use the same one because it worked. And as you can see again, it's downloading the Asset Tracker library. It's pulling in all of its dependencies, and it's now installed. So it's in this libs directory. And if you go see here, we can see the Asset Tracker library and the subsequent dependencies. But it also pulls in the examples that are available on the in the library. So example projects right here. I can start using those for my current application, grab source code from there, whatever, the README that's provided by the developer, etc. So full access to the wealth of library support. And let's see, anything else that I missed, Matt? Anything cool you want to show off? Oh, one more thing. For those who are new to Visual Studio Code, one of the nice things about Visual Studio Code is the configuration management. Everything is driven by config files, JSON files, and the way we've set up Particle Workbench, we do that as well, and we use those for internal management, but they have niceties. So I'm not explaining very well. Let me just show you. There's this workspace file, the code workspace file, which is dedicated to this project. There's a Particle project, and there's a Visual Studio Code workspace, and that's where we can put different configuration options. As you can see, I set that firmware to be 0.7.0. I set it to be Electron. If I start typing here, you can see that same auto-completion is now applied to the workspace configuration. So if you want to move from machine to machine, you can take all that the workspace configuration files and just drop it into another computer that you're working with. That also means you can collaborate and share those configurations with other folks who you're working with. I think that's about it. There's a lot of features, and really the community of Visual Studio Code is amazing. There's great extensions that I've been using every day. I tipped a hat to the Git and the GitHub integration. It's awesome. There's a great demo, which I'm not going to try, and that's Visual Studio Code Live Share, which you can do real-time code collaboration built into Visual Studio Code. You can see it right here. I actually co-designed the theme with our designer while he was in another office. Super cool features, and there's just tons. I want to leave plenty of time for questions or any comments or feedback. Yeah, and thumbs up. Okay, that's the first comment. And yeah. Cool. That's a great question. The question for the audience who's watching this later, is it a separate installation or is it a normal extension you can install? It is using the exact same Visual Studio Code that you have on your machine. We are going to be distributing it as a turnkey installer just to simplify that process. But if you already have Visual Studio Code, it's going to install our extension on top of it and work seamlessly with your current installation. But if you don't, or if you're doing a workshop and you want to distribute those installers to everyone in the workshop, they can easily go get it, install it, and then Workbench is pre-configured and preset. The best of both worlds, I hope. Cool. You. So the question was about debugging capabilities. I actually didn't prepare that demo here, but I can talk a little bit about that. One other great feature that's built into Visual Studio Code is this debugging. I would actually call it a platform. They've defined a protocol for different programming languages and different environments to build against, such that you can build a debugger for Go or a microcontroller. And so it's not wired up on this machine, but this is the standard debugging interface that's available through Visual Studio Code. And through our own configuration and actually an extension developed by the community, we can do hardware-based debugging with something like a JTAG debugger or the new particle debugger, and then do step debugging, breakpoints, all the good stuff you need for working with hardware. There's some niceties about the extension that we're bundling with Workbench. For example, seeing the registers and seeing aliasing to the names of those registers. But yeah, you should be able to go through your C++ code and then do all the greatness of step debugging in Visual Studio Code. I got an OK symbol there. Question in the back. Oh. Sorry, it was a clarification of if this is an extension, if there's an extension you can install. And the answer is yes. So the way that you extend and build on top of Visual Studio Code is through their extension interfaces. So we're in a developer preview now, and we're distributing it as an extension you just go ahead and install. In the future, we're going to have an installer that one-clicks downloads Visual Studio Code if you don't have it and wire up that extension for you. But at the end of the day, that's how you build on Visual Studio Code. We also pull in the dependencies and the tool chains and the particle CLI and a bunch of other stuff on top of it. But fundamentally, it's a bunch of extensions. Well, if you sign up for early access to developer preview, you can get access right now. And we're based off feedback and how ready we feel, we'll make that available more broadly. Sure thing. For the first few releases, there'll be a manual install, and we'll collect feedback from everybody who signs up and make sure you get the right version. Yeah, and then once we deploy it, it'll be available to auto update. Matt, how do you sign up? Thanks, great question. In case you missed it this morning, sign up is a simple sign up form at particle.io/workbench. You just give us the information so we can get a hold of you and get your feedback, and then we'll send you the extension to install into Visual Studio Code. So sign up. Oh, another question. Mm-hmm. Yeah, so the question was, if you downloaded code through Workbench, can you edit that code? Yeah, so it's actually a local copy of the source code available from our libraries service, and it's I'm just going to show you. Back at this project, it's C++ code on your local machine, so you can go in there and change it if you want to have your own custom functionality. Ignore that for a quick moment, and you can modify it. You can pull it. You can pull it in. Similarly, there's a bunch of examples which you can just grab and use that as your main application. And it's a local copy, so if you modify, you don't have to worry about it in the next project because we'll download a fresh one and keep that up to date. So all the information of how to install Particle Workbench and how to start using Particle Workbench, you'll get access to that once you sign up for the developer preview. Another question. If you have existing platform apps on so the question was, if you have existing projects, I was just answering in my head already. If you have existing projects on the web ID, can you use that? Yes, right now it's a little bit of a manual process. You can download all your source code or download on a per project basis and just import that. We're going to refine that and have a more seamless integration between the cloud in subsequent releases. But good question. Yes. Oh, sorry about that. Particle.io/workbench. Cool. Well, this was supposed to be a 20-minute talk, and it was 40 minutes of time. So unless there's other questions, or if you just want to see more features, I'll let you get some time back. And if you want to grab me later and ask one-on-one questions or ideas you have, we're really doing this as a developer review because we want feedback. We want to make sure we do it right before we go broadly with it. And you're a great audience to get that feedback from. And we do listen, and we want to make it as the best possible experience we can. So, thank you.